Good morning, students. Welcome to Scorers 27. So, today the question is the heat of hydrogenation of ethylene from the following data of bond energy is what? Right? So, here it is given as heat of hydrogenation of ethylene. Right? So, what is heat of hydrogenation? First, let us find out what is heat of hydrogenation. Heat of hydrogenation is the amount of energy released when an alkene or an alkyne, that is, when an unsaturated hydrocarbon reacts with hydrogen gas to form an alkane, right? It is also known as the enthalpy change that occurs during the catalytic hydrogenation, right? It is also known as the enthalpy change that occurs during the catalytic hydrogenation. Now, heat of hydrogenation is used to study the stability of this unsaturated compound, right? It is inversely proportional to the stability of the alkene. Normally, the hydrogenation, in a simple sentence, you can say it is a chemical reaction that adds hydrogen to an unsaturated compound to make it saturated. This process is exothermic, right? This process is exothermic, means that it releases the energy, right? The heat of hydrogenation is inversely proportional to the stability of the alkene. This means that more stable alkenes will have smaller heat of hydrogenation, right? Now let's look at this alkane. Hydrogenation of ethylene is an alkene, right? It is an alkene. Alkene has a molecular formula of, that is the general formula of CnH2n. It means 2 carbon, so C2H4, right? Now let us write the molecular structure of ethylene, right? The molecular structure of ethylene is C double bond C, single bond H, single bond H, single bond H. That comes to C2H4 plus H2, that is H double bond H. It gives an alkane, that is ethane. Ethane has 6 CH bonds, right? So here we have 1, 2, 3, 4 CH bonds plus 1 C double bond C bond on the reactant side plus 1 HH bond, right? And the product side we have 6 CH bonds plus 1 CC bond, right? So as you know, the heat of hydrogenation is equal to the sum of bond energy of reactants minus sum of bond energy of products, right? So let us look at the bond energy of reactant side. Bond energy of reactant side is equal to the bond energy of 4 CH bonds plus bond energy of 1 CC bond plus bond energy of 1 HH bond, right? So it comes to 4 into 99 plus 145 plus 104, which is equal to 396 plus 145 plus 104, right? 6, 5, 11, 4, 15, 10, 14, 645, which is equal to 645 kilocalories, right? This is the bond energy of reactants, right? This is the bond energy of reactants. Now let's look at the bond energy of the products. Let's look at the bond energy of the products, right? At the product side, what we have? On the product side, we have ethane. So we have bond energy of products is equal to 6 CH bonds plus 1 CC bond, which is equal to 6 into 99 plus 1 into CC. That's 1 CC bond is how much? 80. So it is equal to 80. 99 into 6, it comes to around 9, 6, 54. 594 plus 80 is equal to 674 kilocalories, right? So now the delta HR, that is bond energy of products minus bond energy of reactants, which is equal to 674 minus 645, which is equal to, sorry, here it is bond energy of, since it is in terms of bond energy, it is in terms of reactant minus products. Sigma bond energy of reactants minus bond energy of products, which is equal to 645 minus 674, which is equal to how much? 40 minus 5 is 9, 6 minus 4 is 4, this is minus 49 kilocalorie per mole, right? So this is minus 49 kilocalorie. So the correct answer is minus 49 kilocalorie. I hope you understood the explanation. Thank you so much.